Hello, so this is a revision video for AP Chemistry 5.9, Pre-Equilibrium Approximation. Not all reaction mechanisms start with the rate limiting step. In some cases, the first step is fast and reversible before the slower rate limiting step occurs. This means the fast step quickly reaches a pre-equilibrium before the slower step. In other words, the fast initial step establishes a dynamic equilibrium between the intermediates and reactants. The slow second step, however, still determines the overall reaction rate. To write the rate law, we can use something called a pre-equilibrium approximation. We express the intermediate concentration using the fast step's equilibrium expression, and we substitute this into the slow step's rate law. This method is closely related to something called the steady state assumption, where the concentration of intermediates is assumed to remain relatively constant throughout the reaction. For example, the overall reaction 2NO plus O2 goes to form 2NO2 has an experimental rate law of rate equals rate constant K multiplied by the concentration of NO squared multiplied by the concentration of O2. Now suppose we have a proposed mechanism of a fast first step of NO plus NO goes to form N2O2 intermediate, and then a second slow step of N2O2 plus O2 goes to form 2NO2. Now, a rate law for the second slow step would be rate equals a constant K multiplied by the concentration of the intermediate, N2O2, multiplied by the concentration of O2. Now, the problem is the intermediate here, N2O2, isn't a reactant, so we can't include it in the overall rate law. However, the concentration of the intermediate, N2O2, is going to be based on the equilibrium between the NO reactants at the start. Now this becomes a bit more clearer when we look at equilibrium in chapter 7, but what this really means is that rather than have the concentration of the intermediate in the rate law, what we can do is substitute in the concentration of that from the equilibrium expression for the fast step. Don't worry if this seems a little bit complicated. The really important thing for you to understand is that if the first elementary step in a mechanism isn't rate limiting, so it's fast and reversible, we have to use approximations to determine the overall rate law expression.